What are thermodynamic parameters? The thermodynamic parameters of polymer solutions are characteristics of behavior of polymer towards solvent, which are the functions of concentration and temperature. I'm Professor Dr. Moina Moghal from Dr. Mchem Institute of Chemistry, University of St. Jamshoro. And today I'm here to discuss with you something very interesting, that is thermodynamic parameters. Now, what do you mean by thermodynamic parameters? Now, you know that therm means that has something to do with temperature, which I just wrote here, temperature, right? Okay, so the thermodynamic parameters include delta GV, delta HV, and delta SV. Okay, so now these parameters are essential for providing evidence about the arrangement and orientation of polymer molecules in dilute solutions. Okay, now the thermodynamic parameters, they comprise of energy, of course, heat, and entropy of activation of viscous flow. Now, the low values of heat and entropy of activation are characteristics of poorly ordered structures, while high value and their sharp decrease with a rise in temperature give information on adequately strong and methodological structures of a scheme or a system. Fine. So now, today I have selected this topic, that is I have mentioned thermodynamic parameters. Now here, if we look over here, now it simply says that the temperature dependence of viscosity is useful in calculating thermodynamic parameters of the polymer. Yes. Now, Frenkle and Erying were the two scientists who developed this method, and they formed some equations which I have referred here. These were related to the absolute viscosity with temperature as, of course, here it is eta equals to AE delta GV over RT. If we circle it with as equation A, where eta is an absolute viscosity, delta GV is the activation of viscous flow, and A is the constant and is in the order of 10 raised to power minus 3 poise. R is the gas constant, and T, of course, is the absolute temperature. Now, the activation energy, that is delta G, can be calculated from A. Okay, that is from this equation, from A. Okay, how you will do that? Delta G equals to 2.303 RT log of eta absolute over 10 raised to power minus 3. Where R and T equals to the gas constant and absolute temperature. Fine. This was something very interesting and very knowledgeable. Let's proceed further to the next slide. Activation energy of viscous flow is related with enthalpy, that is delta HV, and entropy, that is delta SV, of activation, as delta GV equals to delta HV minus T delta SV. If we label it as B, now the Frenkle Erying equation A is modified in a linear form as under, like this. You can here see log of eta equals to log of A plus delta GV over RT, or log of eta equals to log of A plus delta HV minus T delta SV over RT. That is here. And log of eta equals to log of A minus delta SV over R plus delta HV over R and 1 over T. Now, if we label it as equation C, and now we can plot a graph between log of eta versus 1 over T, and you will get a straight line. This is what I have written here also. A straight line is usually obtained by plotting log of eta against 1 over T. That is here. You can simply see. You can see a straight line is obtained when you plot a graph between the absolute viscosity, that is log of eta, and 1 over T. This is, I've also written here, plot of log of eta absolute versus reciprocal temperature for polymers, right? You are going to get this straight line, right? And of course, from the slope, you are going to get from delta HV over R. When you divide delta HV over R, that is here, I've written also, you can see here, that the slope is obtained from delta HV over R, and heat of activation of viscous flow is calculated from equation B, that is from this equation. From here you will be this equation B, that is delta GV equals to delta HV minus T delta SV. You will be able to calculate heat of activation of viscous flow, whereas entropic, this equation will be helpful in explaining you and solving the entropy, right? And entropy can be calculated from this one. Now this equation, that is delta G equals to 2.303 RT log of absolute viscosity over 10 raised to power minus 3, where R and T are the gas constants, and the absolute temperature, which I just wrote here also, is helpful. It's very helpful in evaluating energy of activation of viscous flow from the viscosity of that system. Okay, so now I will now this is a table of free energy of activation of viscous flow at different concentrations and at different temperatures in Kelvin. Concentrations are in grams per deciliters. Now here simply you can see that the energy of activation amplified with the increase in the concentration. It amplified with the increase in the concentration. You can see here the concentration is less, here it's more. So you can see the elevation in the concentration. Now there's a question, why this has happened? This is due to the fact that polymer molecules have fragile or weak associations, right, and can simply overcome during the flow process. Whereas while at higher concentrations, that is here, higher concentrations, the associations are stronger, very much stronger, and little affected during the flow process. This is one of the very visible reasons. Therefore, the values of delta GV are high. That is, Gibbs free energy is high. Okay. Whereas the increase of delta GV with the rise in temperature, it simply indicates that if it increases with the rise in this temperature, it simply indicates the shape conversion of the polymer molecule takes place during the flow process. There is a, what happens that there is a kind of shape conversion is happening, right, of that polymer molecules during the flowing process. The values for delta GV for all the monomers were found to be between 14.1461 to 12.46 kilojoule mole inverse. Okay, and whereas for the polymers there were 14.100 to 15.3193 kilojoule mole inverse. Okay. So this was a little knowledge about, you can say, the Gibbs free energy, delta GV I have discussed, and I have shown you this table also with the concentrations and the temperatures at different values are here, and you can simply see the values and you can see the concentrations and the temperatures. And you will get the idea that how it works, how the Gibbs free energy works on a polymer molecule. I hope you find this video interesting and you have followed few points from this thermodynamic parameters. In my next video, I will discuss about delta SV, that is entropy, and enthalpy, that is delta HV. I hope to see you again. Till then, thank you very much. Allah Hafiz.